Hi, my name is Vincent. I'm a machine learning engineer over at Explosion and one of the engineers that's working on Prodigy, the Python-based data annotation tool made for developers. Prodigy is a very flexible library that allows you to customize the annotation experience with your own Python code. And recently, we've added a new feature in our latest version, version 1.12, that allows you to write custom Python code to determine who gets to annotate which example. This is a very powerful feature because it gives you a lot of control, and it also allows you to specify annotator overlap. In this video, I hope to thoroughly explain how task routers work inside of Prodigy, and I'll be explaining that by writing custom task routers myself in Python. Prodigy has some task routers that you can use from the get-go, but I do think it can be a useful exercise to just write one yourself. This will be a relatively technical video because I will be talking about some nitty-gritty details, but I hope that's also something you find exciting because we do get to talk about some neat hashing tricks along the way. So let's just start by reminding ourselves one more time what problem task routers solve. When you're starting out with an annotation project, you might be annotating by yourself, but eventually, when the project matures, it's more likely that you'll end up with a pool of annotators. And when you have a set of people that can all annotate, there is this new problem, which is how do I map a task to these annotators? And there's a few ways that you could go about this. On one end of the spectrum, you could say, well, I have a task, and each task needs to be annotated by one and only one person. And when you do this, you would get more examples that are labeled, because each example only needs to be seen by one annotator. On the other end of the spectrum, you might instead prefer to say, well, no, each task needs to be seen by everyone. This can be useful in the beginning of a project, when maybe the annotation task is just a little bit less clear, and you want everyone's opinion on each example, just so you can gauge when there's disagreement, and then you can use that as a starting point to improve your process. There are also many situations in between, though, which I might refer to as the partial overlap scenario. And here you might want more than one person, but maybe not everyone. So you could say, for example, out of this group of 4 people, each example needs to be seen by 2. And there are also variants of this, where you could say something like, well, if I have a example here that's very specific, let's say, for example, this is a German example, well, then I still want this to be routed to maybe 2 annotators, but then I have an extra demand. Both of these annotators need to be able to speak German, let's say. As you can imagine, there are lots of ways that you could go about routing tasks to annotators, and this is typically something that's very specific to the problem that you're solving yourself. But given this introduction, I also hope it's clear that there's a lot of value in being able to customize this. Once you understand your problem, it's really nice to be able to make a very bespoke solution for it. So what I'm going to do is I'm just going to make a new custom Prodigy recipe, which is a definition of a labeling interface that also allows you to write custom Python code. And what I'll do is I'll just start by implementing some of these task routers from scratch. And that can be a nice vehicle to also explain what's happening under the hood. So as a start, what I'm just going to go ahead and do is I'm going to make a recipe now where we have a custom task router that just assigns each task to a single annotator. All right, so let's talk about a task router that's attached to a Prodigy recipe. I'm inside of Visual Studio Code over here, and I have a file called recipe.py where I have a custom Prodigy recipe defined. A Prodigy recipe, by the way, is nothing more than a Python function that's decorated with this Prodigy recipe decorator. And the main thing this function needs to do is just return some properties that Prodigy can use to render the annotation interface. So for example, we need to have a stream of examples to annotate, we need to have a name of a data set to write annotations into, we need to have some sort of setting that tells Prodigy what annotation view to use. But the main thing that's of interest in this video is that we also pass this task router setting and that we give it a predefined Python function. Now, this function needs to be of a certain shape. We require a specific signature. But inside of that function, you can apply any logic that you like. And this will be the function that actually routes the examples. So let's have a look at what the function looks like. And here is the custom task router that I'm going to be using in a bit. The task router has a name, and the task router has 3 inputs. It receives a controller, which can be seen as the main delegating object inside of Prodigy. It delegates tasks to other objects, but it also keeps track of a lot of state of the application, and it also has access to the configuration file that has been used. We also pass it a session ID, which is the name of the session that is currently requesting new examples to annotate. We also have access of the current example that is being considered, which is typically a dictionary of content that can be rendered for Prodigy. And then this function will have to output a list of these session IDs. Effectively, we just want to have a list of names to send this task to. Prodigy will then make sure that this particular item is put onto the queue for the sessions that you're outputting over here. Now, in a moment, I will talk about the moving parts, but for now, what I hope is just clear is that we have a custom Python function that returns a list of sessions to send examples to. And inside of this, we can do whatever we're interested in. But in this case, I want to keep it relatively simple. Just whatever session is currently requesting examples, well, that session is going to get whatever item is on top of the pile. We have a list of session IDs defined here with a single session in it. And that's what this task router will return. And this is then the task router that this recipe will be using. So what I will do now is I'll just show you that when I start this recipe and go to Prodigy's labeling interface and actually make it aware of different sessions and users, that it actually does give different examples to different users. So let's start up Prodigy. I have a custom recipe with a name that's defined in this file. Note that the name that I've defined for the recipe over here corresponds with what you see in the terminal. And then this recipe needs a name of a data set to save data into, which is task routing demo in this case. And I also need to give it a source file, which is this examples.jsonl file, which I have to find over here that just has lots of texts of newspaper articles. And the goal of this annotation interface, by the way, is to assign a label of is this a tech article or not. But anyway, the most important thing we're about to see is the effect of the task router. So let's just start this recipe. And let's now open this up in our browser. And when I now go to my browser, I should be able to type in localhost to the port that I'm running Prodigy on. And to indicate that there's a specific user making annotations, what I can do is I can say, well, there's a session name here. And let's say that I, the user Alice, wants to do some annotation. Then there's a couple of interesting side effects. For starters, in the sidebar over here, we can see that there's actually a session name now that Prodigy is aware of. And we can see the first example that Alice gets to annotate. If I were now to open up a new tab and say, well, there's another session called Bob, then we can see that there's a new session name, of course, but we can also confirm that there's a different example to be annotated here. So the queue, effectively, that the Alice user is seeing is definitely different than the one that Bob is seeing. And it also makes sense if you think about the task router that we made. When the task router needs to make a decision, the current session making the request is the one who will get the item. And we can repeat this by saying that there's also another user called Claire. And again, we can see here there's a session called Claire, and we can also confirm that Claire sees a different example. So far so good, but as you might be able to imagine, there's actually a couple of moving parts at this point. And I think it will be good to maybe just diagram a bit, to maybe highlight a bit more what's happening under the hood. So in front of me, I've got a little blackboard with some diagrams that tries to represent the state of the Prodigy app. And the situation that you're looking at right now is a situation where we just started the Prodigy server, but there are no users just yet. So Prodigy has started up. We have a data set that we know we want to write examples into. Maybe there's some configurations that we have around as well. There is this pile of examples that we want to assign to people, and we have our own custom task router. At this point in time, though, there are no users just yet. Prodigy is waiting for the first request to come in. But let's now say that someone actually goes to Prodigy via the URL, and that we know that the session equals Alice is part of the request here. Then Prodigy, right now, is aware that there is a user called Alice who wants to start annotating. So as a next step, Prodigy will actually make a session for Alice. Now, for our intents and purposes here, there are two parts of the session that are important. First of all, the session has an identifier that can be seen as a unique name of the session. If the session name via the URL is Alice, then that will be combined with the name of the dataset that we're writing into, and that's going to be the session name. This way, if the same user is writing into a different dataset, we will have a different session name for that. In this case, that means that ner news Alice will be the name of this session. The second important property is that a session also has access to tasks that the user will need to do, which can be seen as a queue. And it's the goal of the task router to take examples from our big pile and to route them into the queue of these sessions. So right now, we are at the point where the session doesn't have anything in their queue, and therefore the task router will kick in. And hopefully at this point, it's also clear what the task router function has access to. So at this point in time, we have the controller from Prodigy that the task router has access to. We also have the name of this session over here that the task router has access to, as well as the next item on the pile that needs to get routed. And from this, we have to create this list of session names to route these examples into. But now, in the current implementation of this function, we might have access to all the known sessions that the controller has access to, but we're not really using that because we're saying, well, the session that's making the request to the task router, that's the only session that gets to have the example. So that would mean in this case that the first example that we see here gets passed into the session for Alice. The second item will also go there. And the third item will also go there. And then at this point, we could say, well, that's a full batch. That's enough for Alice for now, which means that the task router is done for now. Only when Alice needs new examples because the batch is empty, will the task router be routing tasks again. That is, unless there's a new user that makes an appearance. Because now, let's say that we have a user called Bob that also comes to Prodigy. Well, then Prodigy again becomes aware of a new session. And this new session will also need new tasks, and then the task router basically kicks in again. In this case, though, the first couple of items are already assigned, so we're going to move on to the next one. So Bob, you could say, would get task 4, 5, and 6. And as you might be able to guess, when Claire then comes around, we again make this new session, the task router kicks in again, and in this hypothetical example, Claire might see examples 7, 8, and 9. Now, of course, when these queues become emptied, the task router would start routing again. But I do hope that the relationship between what's happening under the hood and the part that this task router function plays, that's maybe just a little bit more clear now. So at this point, you might say, well, this looks simple enough. So far, so good. But there are already a couple of caveats to just kind of be aware of. And to maybe explain that, let's now just consider a new task router. Before, the task router would really just return a list with this session ID, that is the session that's making the current request. But right now, I'm doing something different. I'm saying, hey, let's return all the sessions that we have available in the controller. The thinking here is that this might be a task router that will assign each of these tasks to everyone. And although the idea here is pretty sound, there is a pretty big edge case that we have to be aware of. Because here's what happens. Let's say now that, again, Alan pops around, and that, again, a session gets made. Well then, let's now think what would happen with this particular task router. This task router would look at the pile, and at this point in time, it will look at all the sessions that are currently known. At this point in time, that will be Alice, so Alice will get items 1, 2, and 3. But now Bob makes an appearance. Again, a session gets made. The session needs tasks, so the task router is triggered again. And in this case, we are considering item 4 to go in here. The session ID ner news Bob will be going in here. But this controller at this point in time is aware of 2 sessions. So we're not just going to be routing tasks to Bob, we will also be routing them to Alice. So that would mean that Alice would get task 4 in the queue as well, just like Bob. Same with item 5 and item 6. Because only at this point will Bob have a full batch, but that also means that we have a bit of an imbalance here. Alice will have 6 items, whereas Bob will only have 3. And this will happen again when Claire comes around. Again, following the same logic, task 7 will get routed to everyone. Task 8 will get routed to everyone, and task 9. Now you could argue, maybe this is not such a big deal. Maybe we can be fine with having a few examples that only get routed to a few people instead of everyone. But at the same time, this is a phenomenon that's pretty important to be aware of if you are writing your own task routers, and if you want the routing to be very consistent. And also, by the way, there is a solution to this problem, which is also good to be aware of. What you can also do when you start Prodigy, which would be the elegant solution in this case, is that you can say, well, let's just make Prodigy aware of all the users up front. We have an environment variable called Prodigy allowed sessions, and this allows you to just pass in a list of names, so to say. That list of names will just be used to create sessions up front. So even if none of the users have shown up yet, we are still able to make a session on their behalf. And this way, Prodigy is aware of all the users that will show up. And the nice thing about that is then, when a user actually does show up, so again, let's assume that Alice is the first person, then at this point in time, the task router will be triggered. And at that point in time, this controller object will be aware of all three of the sessions. And that means that this annotation pool that we return will also contain all three of those sessions. And that means that the first item will be assigned to everyone, then the second, and then the third one. This is why, in general, if you are writing custom task routers yourself, it is recommended to consider using this environment variable, just to make sure that Prodigy is aware of every single annotator out there. So just for good measure, I figured it might be good to demonstrate the behavior that I just drew in my diagram. So what I've got here is my router.py file with my custom task router. And you'll notice that what it's doing is it's saying, well, the annotators that I want to return, that's the known session IDs from the controller. But then what I'll also do is I'll just do a little bit of logging, just so we have some confirmation of how tasks are being routed, right before we actually return a list of annotators. And by doing this, what I can do now is run the recipe again. And from here, what I'm going to do is I'm going to go to my Prodigy endpoint, and I'm going to pass the session name that is equal to Alice. Pay attention to what's happening in the logs here below when I do this. So when I do this, we can see that indeed 3 examples are properly being routed to Alice. And just as an important detail, note that the reason why we're routing 3 examples is because I've got the batch size equal to 3 over here in my prodigy.json file. This file also determines, by the way, that we're running this on a specific port. But anyway, back to the interface here. Let's now have a look at what happens when I say, well, now I'm going to annotate as Bob. Well, then now we see that the next 3 examples from the pile get routed to not just Bob, but also to Alice. That's something that we can confirm in the logs here. And if I were to expand this and say, hey, let's also route to Claire, well, then we can see that it's routed to everyone. But we can also see that if we just have a look at who gets all the examples, Alice at this point in time has received 9, whereas Bob only has 6 and Claire only has 3. So let's now run this again, but with the environment variable. So Prodigy allowed sessions equals, and I'll say Alice, Bob, and Claire. And let's just see how the logs are different when I do this. So I'm back in my browser, and let's see what happens when I trigger a task router for Alice. In this case, because the sessions already exist, the controller is aware of all 3 of these different sessions, which in turn means that our custom task router can actually route tasks to these users. And that, I think, is a nice demo, because it's important to understand how sessions are created in order to write your own task router. So I hope you agree that in general, there's a good reason to run your recipe with this environment variable. There are, however, still some consequences to also be aware of. If you decide to actually configure the known sessions up front, then that also means that no other sessions can be made. If these are the 3 annotators that Prodigy is going to be aware of, then you're not allowed to add a 4th one, let's say Dave. That's something that won't be allowed. So if you are in a situation where you end up having very dynamic users coming and going, then you are going to have to accept that that flexibility may come at the cost of some consistency in your custom task routers. Having said that, this might also be a good point in time to mention that you don't always have to write your own task routers either. From the prodigy.json file, you can configure feed overlap. And what you could do is you could say, yeah, I want everyone to see each and every single example. Or you can define feed overlaps to be false, in which case you're saying each example will only be shown to one annotator. And alternatively, if you're interested in partial overlap, you can also set the annotations per task property to basically say, well, I want each example to be seen by 2 people, maybe 2 out of 3 if you set this parameter. So if those settings make sense for you, then you don't necessarily have to write your own task router. You can just use this configuration file, and then on your behalf, Prodigy is going to provide a task router for you. However, in this particular case, Prodigy would also be able to do something more on your behalf. You see, when Prodigy starts up, we have a controller with some settings. And in the case that you are using our config file, then we might be able to do more on your behalf. And in particular, when a new user shows up, then there is this moment where a session gets created, and that creation process happens via something that's called a session factory. Just like the task router, a session factory is a specific Python function that can create a session on your behalf. And the nice thing about this session factory is that it's able to see some of the settings that you've passed in this configuration file. And that means that when this session actually gets created, Prodigy might be able to do some clever things on your behalf, such as check the database if a specific user already has made annotations, or check the database if other users have made specific annotations for specific tasks. And that means that on your behalf, Prodigy might be able to configure the task router and session factory in such a way for you that you might not need the Prodigy allowed sessions environment variable. So my advice in general is that if the task routing needs that you have can be met by our prodigy.json file and its pre-configured task routers, that you just go ahead and use those, because we're able to do a lot of clever things on your behalf. However, if you are doing something that's relatively custom, then it is important to just be aware of the way that sessions get created, because the session needs to be around in order for the task router to be able to route a task to it. Now, if you're interested in learning more about this session creation aspect, be sure that you read the section on the session factory in the documentation. If you really want to, you are even able to make your own function that creates sessions. Just be aware that this is a somewhat advanced feature, and that you might not need to go this far when designing your own task router. But if you really want to go the extra mile and have full control on how a session is created, you can do so. So far in this video, I've been talking about all the stuff around the task router that makes it work, but now it might also be good to talk about some techniques that you can use within the task router to do some consistent routing. Because there's still some interesting problems that we might want to solve inside of these functions. For example, let's say that I have a pool with 5 annotators, and that I would like to have each task be... Then one thing that you could do is you could say, let's just pick 3 random people by using some sort of random number generator in Python. To an extent, that might work. So let's assume that I've got this router. Let's then also assume that this one specific task comes around. We use the available pool, and then we might use random numbers to say, okay, A, B, and let's say E, these people get to annotate this one example. But now, let's say, the server restarts, and then this one task comes around again. Well, then, because we're using a random number generator, we might now route tasks to C, D, and B. And this is the downside of using random number generators. Every time that the server restarts, you're going to get a different allocation, and that's probably not what you want. Instead, what you really want, preferably, is to just have a mechanic such that if the annotators remain the same and if the task remains the same, then we always have a consistent mapping from task to subset of annotators. And there is a hashing trick that you could use to do this, which I figured would be good to share here, because it's a pattern you might use generally in your own task router as well. In Prodigy, every task that you have for annotation will have a hash attached. It could be a hash of the text that you're annotating. It could also be a hash of the label plus the text that you're annotating. But in general, for each task, we can definitely come up with some sort of hash. And that's a consistent mapping. The same example will always have the same hash. There's no way to predict upfront what this number will be, but it will be a one-to-one mapping. And that allows us to do a cool trick. Because if the hash is known, and if this pool of annotators is known, Then we also know how many annotators there are that we have to distribute this task amongst. So what we could do is we could just say, take the hash value, take the mod of that hash value, that is to say, when we divide everything by 5 and look at the remainder, what number do we have left? Now, and in this case, that would be the number 1. And if I assume that we have a list that starts at index 0, then taking the mod 5 of this hash is going to give me this annotator. So I could move that annotator into my current selection pool. Now again, the thinking here is that the hash number that I have here, to some extent, can be seen as a random number because it's unpredictable what the number will be. But it is deterministic in a sense that the same example will always have the same hash number. And this already on its own is a cool trick that allows you to consistently map a task to a random user from the annotator pool. But if you want to have multiple annotators, you're going to have to extend this trick a little bit, because we're going to be iterating. If we've made one selection right now, that's great, but we might need to make another one. However, we can kind of repeat the same process if you think about it. Before, we took the mod of 5 because there were 5 annotators in the pool, but now, because there's one less annotator to pick from, we can just take the mod of 4. Again, the same argument would apply. We have a consistent mapping from task to hash, and because we've already selected this annotator, we again have a very consistent way of selecting the second one. In this case, because we take the mod, we have the remainder of 3. Again, because we start at 0, we would now select this annotator over here and add that to the selection. And this is still consistent, and we now have 2 random annotators. And we can repeat the same trick for more. If we now want to select another one, then we will have to make sure that the annotator we previously selected is no longer available. But we can apply this trick for as much as we'd like, until our selection is as big as we're interested in. And this technique can be very useful if you're writing your own task routers. So what I would like to do real quick now is just show you an implementation of this trick, and then I'll also discuss how you can customize it further if you would like. Okay then, so I am back in Visual Studio Code, and I have updated this task router over here. The way that it's currently set up is to pluck 2 random annotators from the annotator pool, and it's going to be using the hashing trick that I mentioned earlier. One thing that's actually kind of important here is that when I go to my recipe, you'll notice that when I load up the stream over here, that I've actually set the rehash setting to true. That is going to make sure that there are actually hashes that I can use on each item. You can also do this manually yourself, but this is a nice way to make sure that hashes are around. And that means that each item that I'm going to get here is going to have a task hash that I can use. So you can see here that I have a hash value, then I have the index from my annotator pool, which is the hash value mod the length of the pool. And then here I'm using a while loop effectively to keep on going until I have the number of annotators that I'm interested in, or if I've exhausted the pool of annotators, which is also something that could theoretically happen. Also, just like before, I am logging. So what I can now go ahead and do is pop open the terminal, and I can run the same recipe as before, but now with this task router. And we can, again, see what is happening because we're also logging. So, all right, I'm going to say session is Alice. Alice is one of the allowed sessions, so that should be fine. And let's pay attention to what logs we get here when I hit enter. So what do we see? Well, the first example gets routed to Bob and Alice, and the second one gets routed to Bob and Claire. So that second example is not going to Alice, and that can happen because there's this random effect in here. So we're going to keep on going until Alice has a batch size of 3. So here we've got Claire and we've got Alice, so that's the second item for Alice. And here we've got the third one for Alice. So that's the point in time when the task router stops getting triggered. But what's pretty interesting here is that at this point in time, Alice has 3 items in the queue, Bob has 1, 2, and 3 items in the queue, and Claire has 2. Now, of course, this is a relatively basic demo, but if you were doing this for larger numbers, you should also see that indeed we also get a somewhat even distribution amongst the annotators, which is also usually what you're interested in. which is also a nice property of this hashing trick. You do get tasks that are evenly distributed in the long run, which is great. So there we are. We have discussed how session creation can influence how tasks are routed, and we've also discussed a general hashing trick that's useful. So as far as theory goes, I think those are the main building blocks that you can use to start working on your own custom task routing. As a final tip, though, I do recommend having a quick look to the documentation page. In particular, if you go to this task routing section, then you can scroll down to the bottom to see a couple of example implementations, just kind of as a source of inspiration. So the first example that's listed here uses the hashing trick that we just explained, but it also does something extra. Because a task router has access to the controller, and because the controller has access to the database, you can use every single method that the database class exposes inside of your task router, which means that you can check the database state before you actually route examples. And that can be very useful if you have a very specific but strict requirement. Now, the example that's below that I think is pretty interesting too. Let's assume that we have some sort of a model that we are using in the mix, and that this model is able to output some sort of a confidence score. Then you could argue, well, if the model is very, very certain, then maybe we don't need that many annotators. But if the model is pretty uncertain and we get a pretty low confidence score, well, then maybe that's an example that everyone should just have a look at. And this is kind of a nice example of branching logic using a model in the loop. And I like this example because it also shows how you can just kind of get creative inside of these task routers. The task router is just written code in Python, so anything Python can do, you can do inside of this task router. And then we get to the final example on this page. This example will route tasks based on data that's available in the item. So we could say, for example, if the language property in that item is Dutch, well, then we're going to send it to Vincent. If it's German, we're going to send it to Ines. Or if it's Australian, we'll send it to Matt. That's logic that you could build in. But a cool thing about this particular recipe specifically is that it also makes use of some new methods that we've added in version 1.12. Methods that are helpful inside of a task router that are attached to the controller object. In particular here, the name Vincent is being passed into this getNameAndConfirm function. And Vincent might be a name of an annotator, but it might not yet be a session that is around. So what this function can do is it will be able to take a name. It will then be able to get the appropriate session name that has the dataset prefixed. And then we have this controller method called confirmSession that will just confirm if the session is around, and if it's not, it will just use the session factory to create a session on your behalf. That way, you are always sure that the session Vincent exists when you write a task to it. If you're interested to learn more about these helper functions, if you go to the components and functions section of the documentation, you will find a definition for the controller class, and you will also find lots and lots of methods that you can use inside of your task router. And if you scroll down, you will also find some of the methods that we've added in version 1.12, and a lot of the times these methods were added to help you write task routers, so definitely feel free to have a look at this. I hope you found this tutorial useful, and I also hope that you just feel free to get creative with these task routers and to really make some bespoke solutions for your annotation process. Thanks for listening.